It's hard to believe that the first 802.11 standard came out way back in 1997. Since then, 802.11 has pretty much taken over the universe as our primary wireless technology that we use for our wireless networks. Now you can imagine, over time, we've had a number of standards that improve on the 802.11 standard, and that's what this episode is all about. We're going to go through all of the 802.11 standards that you're going to be seeing on the A+, and let's start with 802.11b. 802.11b was arguably the first big popular 802.11 standard. 802.11b ran at the 2.4 gigahertz ISM band, and it ran, which at those days was a whopping 11 megabits per second. It's got a lot faster. I like 802.11b because it was the introduction of these famous little routers that began to be seen all over the place by a little company called Linksys, the famous black and blue routers that slowly took over the entire world. Now, 802.11b wasn't the only standard that came out at about the same time. The other one I want to talk about is 802.11a. 802.11a came out at roughly the same time as 802.11b. Now, 802.11a ran at the 5 gigahertz band, and it also ran at a whopping 54 megabits per second. Now, that's kind of interesting because if 802.11a and 802.11b came out at roughly the same time, and 802.11a ran so much faster, well, why did B become so much more popular? Because it did. The reason is simple. First of all, 802.11a, when it first came out, had a couple of technical issues that made it difficult for normal people to use in a wireless environment. Secondly, 802.11b had a much wider range, so I could drop an 802.11b wireless access point and serve a lot more people. So 802.11a and 802.11b, while they came out at the same time, really B was the one that kind of took over the world. So we now live in a world where we had A and B, but we wanted the robustness and speed of A and the popularity of B, and that's where we came up with something called 802.11g. If there is one Wi-Fi standard that really just kind of took over the world, it would be 802.11g. 802.11g in essence took all the chocolatey goodness of 802.11a and 802.11b and put it together in one standard. So 802.11g runs at the 2.4 gigahertz band, but it runs at 54 megabits per second. And we just saw 802.11g everywhere. Now, you got to be a little bit careful here because we're talking about two different bands. So if I have an 802.11g wireless access point, because it runs on the 2.4 gigahertz band, if I have old 802.11b clients, it can talk to it just fine. But if I have something that's 802.11a, the radios in the wireless access point run in a different band. They run in the 5 gigahertz band, so there is no compatibility. We'll see that that becomes an issue with later standards, and let's start with 802.11n. The 802.11n standard brought in a whole new level of complexity into our 802.11 networks. So in order for me to explain 802.11n to you, I wanted us to take a look at this old 802.11g wireless access point. You'll notice it's got two antennas. So for 802.11a, b, and g, you had one antenna that sent and one antenna that received. Now, the 802.11n standard began to change things. Number one, it ran at both the 2.4 and the 5 gigahertz bands, so that's interesting in and of itself. And it ran at a top speed that I'm going to dispute a little bit, but we'll just say 600 megabits per second. So this is an 802.11n wireless access point. 802.11n introduced something called MIMO. Now, what MIMO did is it brought in the idea of data streams, where you could actually send more than one piece of data, if you have enough radios and enough antennas, to an individual client or to groups of clients. And with MIMO, each one of these would create a stream, and you could, in essence, double, quadruple, up to 4 streams in 802.11n, which was pretty cool. The downside to 802.11n, more than anything else, is the fact that it would work in the 2.4 gigahertz band. And that was a bit of a challenge in that you can set up a wireless access point to run in the 2.4 gigahertz band for 802.11n, but it will literally stomp almost anything else out there. So most properly configured 802.11n wireless access points only did their 802.11n stuff in the 5 gigahertz band, and even though they did have 2.4 gigahertz, that was usually reserved for backward compatibility with 802.11b and G. It really wasn't until 802.11ac that we began to see the standard really tighten up. The 802.11ac standard is really a pretty cool standard. First of all, it runs exclusively at the 5 gigahertz band. And when it comes to speed, it gets a little complicated to say how fast it is, but the idea is that it should run about 1 gigabit per second onto an individualized client. Now, 802.11ac has a lot of really cool features. One of the things, and you'll see this on a lot of modern wireless access points, is that they have lots of antennas. They're just built into the wireless access point. Trust me, there's lots of antennas in here. So the first thing that 802.11ac has is up to 8 simultaneous streams with its MIMO, but not just that. It has what's known as multi-user MIMO, and that allows it to support up to 4 individualized clients simultaneously. Back in the old days, you talk to one client, then you talk to another, then you talk to another in a pecking order, but with multi-user MIMO under 802.11ac, you can talk to up to 4 individual clients at once. All right, now we have gone through a number of different standards here, and I assure you that A+ is going to be asking you detailed questions on it. So to help you out, what I want to do now is put up a table of all the different 802.11 standards and the important information that you need to know for the exam.